These are the questions in NEET 2020 and 21. Both are from magnetism and matter. Both are basing on the same concept. So, first we will solve this simple problem and then we will come to the other problem, that is NEET 2020 problem. It says a wire of length L meter carrying a current I is bent in the form of a circle. So, it is in the format of a circle. Its length is nothing but the circumference of the circle. So, circumference of a circle L is 2 pi r. So, what is the radius of the circle is L by 2 pi. Then its magnetic moment is, when a conductor is carrying a current I, it behaves like a magnet. It will have a north and south pole, like a physical north and south pole, and the magnetic moment of that current coil has been proved as NIA, where N is the number of turns. In our case, number of the turns is 1 because it is only a wire of 1 L being bent. Current I is I itself, as it is given in the problem, capital I. Area of that circle can be written as pi r square, but radius is given, not given, but length is given. So, in the place of radius I can write L by 2 pi whole square. This is pi L square by 4 pi square. Knowing all of them, we can substitute and find the magnetic moment as NIA. N is 1, I is capital I, area is pi L square by 4 pi square. 1 pi can be cancelled. So, the answer is I L square by 4 pi, ampere meter square of course. So, I L square by 4 pi, option D is the answer for the problem. Once if you solve that problem, this other problem becomes quite easy. Look at this problem. A uniform conducting wire of length 12 L and resistance R is wound up as a current I is carrying coil in the shape of an equilateral triangle of side A. So, let us consider case 1 as an equilateral triangle. When a wire is bent like an equilateral triangle, if you draw the area of the if you draw an equilateral triangle, this is how it looks like. It was given that each side is A. So, this is A, this is A, this is A. So, the total circumference of this is 3A, but there is totally 12A length. Therefore, like this it was being done 3 times, each one has to become 3A. So, that all together, it has to be done 4 times, 4A, 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 that means altogether it becomes 4 3 is 12A. That means what? It is bent with 4 turns, like 4 triangles of each of side A. I know the formula for the magnetic moment is NIA. Now, I got N equal to 4. And it is also given that current is like capital I. Area of this triangle is how much? We do not know. So, to find the area of a triangle, we know we have a formula. Area of the triangle is half into base into height. Half height is I have to find out. This is totally A, so this is half of that, A by 2. For one triangle side is A, then this is the height h. H can be written as for the Pythagoras law as A square minus A by 2 whole square, A square by 4. So, that becomes root of 4A square minus A square, 3A square by 4, that is root 3A by 2 is the area. So, area of the triangle is root 3A by 2. Now, what we have found is not the area, we have actually found is the height of the triangle. So, to find the area of the triangle, I have to use the formula half into base into height, half base of this triangle is equilateral triangle side A, height we have found as root 3 a by 2. So, the area of the triangle is root 3 a square by 4, and we know the magnetic moment is, as we have discussed, NIA. N is 4 turns, because each of side A, so triangle is having 3A, there shall be 4 like that. I is capital I, area is root 3 a square by 4. So, this 4 and 4 will cancel. So, the answer remaining is root 3 I a square. So, you can see where that root 3 I a square is there, it is actually there in option A, there is nowhere else. So, I can consider that as an answer, but let me do the second part of the problem also, just for the sake of continuation. It is now bent like a square of side A. So, this is a square A. So, the total length is 4A, but the total wire available is actually 12A. That means it is made up of 3 turns, with each turn 4A, 4 into 3 becomes 12A. Therefore, in this case n equal to 4, in this case also I is capital I, area of a square is length into breadth a square. Knowing all of them, I can find out magnetic moment as NIA, n is 3, I, area is a square. So, 3I a square is the option, that is the second option available, right. So, that is how we have to get the answer, right. So, option A is the answer. So, to solve this entire problem, we need to know only one formula, that magnetic moment of a current carrying conductor is NIA. Once if you know that, solving the other parts of the problem shall be an easy task. That is how we have to solve the problem. Thank you for watching.